Hello, everyone. This is Nantia Iakovidou speaking. I'm glad to be with you today, and I'm really excited to present to you how we use the OpenSpecimen tool, in our case, to build the Biobank Information Management System. First of all, a biobank can be defined as a searchable, organized collection of human biological samples that are linked to the relevant personal and health information records. This basically means that all the samples that are being collected and stored cannot be anonymized. They have to be connected to the relevant personal and health information data in order to contribute in improving health and medical research. However, the data can be pseudonymized, and this is actually what we apply in our case. We apply pseudonymization of the data through OpenSpecimen. On the left, you can see the well-known OpenSpecimen hierarchy, and on the right, there is the general biobank workflow that we follow in our case. First of all, I have to mention that it is only after the donor signs an informed consent form that this workflow begins. The first step of the biobank workflow includes capturing information by the nurses regarding the personal, contact, and demographics data of the participants, and also several clinical, physical, and socioeconomic information. After that, the samples collection follows, that is being again performed by the nurses. And the last step of the nurses' workflow is the shipping of the specimens, which practically includes transport of the samples from the collection site to the central lab. Of course, specialized boxes that fulfill the requirements for compliant transport of the samples are being used for this procedure. The next phase includes reception of the shipment, which means reception of the specialized boxes that include the primary specimens from the lab technicians, and after that, the reception of each specimen individually follows. The next phase includes processing and storing of the samples, and the final step of the biobank workflow includes the specimen distribution. As you will see later, in our case, we have created two collection protocols, the one for diagnostic purposes only, and the other one for research purposes. Now, the legacy system that managed the biospecimen life cycle before the BIMS was a combination of an in-house developed web tool that included a MySQL database that was storing several types of metadata, physical forms like the one on the left, Excel spreadsheets, and this is an example of freezer management in handwritten form. Anyone can see that this approach had no provision to trace the detailed transaction of the samples. It was, of course, inadequate and did not support any auditing of the samples. On top of that, using physical forms, which means entering all the information manually in a piece of paper, had led to numerous mistakes in the collected data. So undoubtedly, there was a significant need to implement a biobank information management system in order to facilitate the staff members' workflow. After the relevant research in the market, we ended up to the conclusion that OpenSpecimen Enterprise Edition was the best option to help us implement the biobank information management system that includes, but it is not limited to, all the features that are listed here. If I had to highlight a couple of these implementations, I would definitely highlight the achievement of automated labeling, barcoding, and printing. In the biobank, we print labels for every single specimen. Imagine that before the BIMS, the users had to manually prepare every single label and also to manually print all the labels, which you can imagine how much time-consuming and tiring task it was. This was also achieved by using an additional labeling software tool, which was set up in parallel with OpenSpecimen, and they now work in tandem. Another implementation that I would like to highlight is that by exploiting OpenSpecimen features, such as, for example, custom forms, custom fields, events, queries, and of course, through configurations of the source code, we managed to be able to record and monitor the quality requirements of the specimens. I have prepared a couple of demo videos that show the phases of the biobank workflow. This is the homepage of OpenSpecimen. You can see here the 2 collection protocols that I mentioned earlier. This is our ID management policy. We're using 2 separate unique IDs. One is being used for internal purposes only, and the other one is being disseminated to external collaborators and labs. We also have the family ID number, which is used to cluster participants together that belong to the same families. And finally, the other IDs field includes any other possible ID that the donor might have, apart from the other 3. This is the participants registration page, which has also been customized. New fields have been added, like, for example, the names in Greek, the telephone number, the mobile telephone number, the personal doctor's name, and several upload fields in order for the users to be able to upload the signed consent forms at the participant level. After that, the samples collection follows by selecting the corresponding visit event. This is the table of the pre-specified primary specimen requirements that was defined through the system. And this is an additional screen that was not present in the default version and was added through the JSON file, through configurations of the source code, in order to give the users the possibility to capture additional information at each visit. After that, the final step of the nurse's workflow includes the shipping of the specimens. A nurse can very easily create a new shipment by entering a unique name for each one of them. It is also mandatory to complete the sending and receiving sides of the shipment. And on the next screen, the nurse can very easily scan the primary specimen's barcode and create the list of specimens to be shipped. As you can see, no personal information is being included in the specimen labels, and all the samples are being pseudonymized. This is the reception demonstration procedure. Lab technicians perform, first of all, the reception of the shipment, which means the reception of the specialized boxes that contain all the primary specimens. At this screen here, they are also able to edit the available quantity of the specimens. And after that, the reception of each specimen individually follows. Again, the lab technicians are able to scan inside this box the specimen barcode number and declare in the system which primary specimens are being received. From this table here, the receive event is automatically created and attached at the specimen level. This is again an additional screen that was not present in the initial OpenSpecimen version and was added through the JSON file, through the source code. These 7 fields here constitute the transport event that is being automatically created from the screen and attached at the specimen level, and is being used to monitor quality requirements of the specimens during transport, such as, for example, the temperature that the samples were shipped, whether a thermometer was used, whether any non-conformities occurred, and things like that. The next step includes the processing of the samples. I have created a query for this purpose that is specifically addressed to lab technicians. So in this query, by entering the today's visit date on the filters on the left, lab technicians can automatically see currently available, already collected and received primary specimens that are still unprocessed. And by selecting samples that belong to the same specimen type, at this particular example, the serum specimen type, they are able to create the corresponding process event by entering information about the centrifugation procedure, for example, about the date, time, and duration of this process. This is a drop-down field so that lab technicians can enter the necessary information according to the case. They can also enter information about the quality of the specimen after processing, and etc. After this step, you can see that automatically the corresponding process event is being created and the processed specimens are being automatically removed from this list. All these process events were not present in the default version. They were created specifically to serve the purpose of monitoring and capturing and recording the quality information of the specimens. A corresponding process event was created for each specimen type. This is again an example of a process event for the plasma specimen type. Again, lab technicians can enter all the relevant information. And at the end, we can see again that this specific primary specimen that has been processed is automatically removed from the list. Now, if we enter the specimens level and click on the Events tab on the left, we are able to see all the events that correspond to the whole life cycle of the sample. These events are sequential. The first of all is the collection event, which corresponds to the moment that the specimen is actually created. All the rest of events can be found here: the shipment events, the received events, the transport processing events, the transfer events that refer to the case when moving a sample from one storage location to another, and finally the disposal event, which means that this particular sample is no longer available at the biobank and it is marked as closed. This is an example of freezer management. Storage containers and freezers were not present in the default version. They have to be created from the person that is setting up the whole system. This is an example of a freezer storage container with dimensions. In this case, the storage container has shelves, racks, drawers, and boxes. The lab technician can, again, very easily store a sample by just clicking in this box and scanning the specimen's barcode. Lab technicians are also able to select a specific position inside the box to store the sample. Also, a specific color code can be assigned to each specimen type. In our case, we have in total 7 freezers with dimensions, 3 storage locations that are dimensionless, and 1 storage location that is a combination of both. Half of it has dimensions and half of it is linear. This is another important feature that we use, the specimens catalog. The filters on the left and the columns of the catalog can be customized and have been customized in our case. As you can see, no personal information is being demonstrated in the specimens catalog. The catalog is mainly used by the researchers of the organization. They are able to search the desired specimens by entering the necessary filters on the left. At this particular example, we can see all the available specimens that correspond to participants below 18 years old. In this case, researchers can very easily select the specimens that they wish to study by just clicking on the corresponding record and add them to the cart. And after that, of course, they have also to submit their request to the biobank. So after submitting a distribution request to the biobank, the request manager can either approve or reject the request. In case that the request is approved, it can be processed further by the lab technicians, and once it is processed, it is then marked as closed. So basically, this is the researcher's workflow in the biobank. In our case, we have 3 distribution protocols. The first one is the internal distribution protocol that refers to the case when researchers from inside the organization request samples from the biobank. The second one is the external protocol, when specimens are being sent to external collaborators and labs. And of course, the destruction protocol that refers to the case when participants wish to withdraw their samples from the biobank. Apart from designing and implementing the whole system, it was also necessary to perform an important part of data migration before the system goes live. The reason was that in the biobank, we do not only have newly registered participants, there are also already registered participants that come for follow-up visits every day. So their corresponding participant and visits data had to be migrated in the system in order for the users to be able to work properly. Consequently, almost 6,500 participants' data, along with their corresponding visits data, have been migrated before going live by using CSV bulk import files. And of course, in order for all this data to be migrated, they had first to be corrected, because as I mentioned earlier, there were many mistakes in the data. For example, there were cases when people that had the same nationality had also the same national ID number, which is not possible. Consequently, all the data had to be corrected and then migrated in order to go live. And of course, the users training was a really important task. It was intense and time demanding because all users had to dedicate significant amounts of time to learn and practice the new system that was totally different compared to what they were using before. All the training procedures took place in the BIMS testing environment, which was, of course, identical to the production environment. And as a result, all users are now well trained regarding their daily workflow steps and know exactly how to operate the new BIMS. These are a couple of examples of aggregated reports. Again, these were not present in the default version. A person that knows how to use functions and operators and how to combine all this together has to create these reports. And also, of course, this person has to know which variable specifically to use in order to create the desired results. This is an example of aggregated reports that shows the total number of female participants per research project. And this is a demonstration example of a table that shows the totals of available aliquots and derivative specimens by specimen type. To conclude, overall, the task of designing and implementing an information management system for a biobank that had already been collecting specimens for more than 10 years now, while using insufficient resources for recording and auditing information, it was a really painful and difficult task. It was just recently that the biobank got enough funding to build a biobank information management system. And unfortunately, it required a lot of time and effort to finally produce the finalized systems and users' workflow, while at the same time fulfilling past, current, and future biobank requirements and needs. Despite all the difficulties, the system is currently live for the past 5 months, serving the biobank's demands and being able to accomplish its goals of effectively performing data management and auditing every action in the system. And all these by minimizing at the same time the time costs and by preventing human errors. I believe that the transition from the old to the new biobank information management system was smooth due to the exhaustive testing and training procedures that were followed. The BIMS was also one of the biobank project's deliverables. It was successfully submitted. As I mentioned, an important part of data migration has already been completed. Of course, the specimen level data migration, it is still an ongoing task. It is a huge task if someone considers that there are 8 freezers almost full of specimens, some of them having a capacity of 50,000 samples. Also, the corresponding primary specimen information and all the relevant information about the already distributed specimens has also to be created in the system. And this makes it even more difficult if we consider that there was insufficient means for recording and auditing information in the past. We are also about to apply an automated liquid samples handling system in the near future. And what we are actually planning to do really soon is to publish a journal paper about the BIMS case study. This paper is almost on its final stage of preparation, and I believe that it will be submitted soon. So when it's published, I will be more than happy to share this with you. And I will be also more than happy to share my presentation slides with anyone that is interested. And of course, I remain at your disposal for further questions or discussion. Thank you very much.